Right, here we're going to have a look at solutions to equations of the form dy by dx is equal to function of x multiplied by a function of y, where the function of x is a function of x only and fy is a function of y only. To do that, we arrange all the y terms to one side of the equation and all the x terms to the other side of the equation, and then find a solution by direct integration, which we'll do through following an example. And this is example 4 in the notes for this week. So we're looking at solving the equation 4xy times dy by dx is equal to y squared minus 1. If you want to have a go at rearranging that, pause the video and have a go now, then come back and follow the solution. So looking at that problem, we first multiply both sides of the equation by dx. We end up with 4xy times dy on the left hand side, y squared minus 1 in brackets times dx on the right hand side. Then divide through by the bracketed term y squared minus 1. We end up with that, 4xy over y squared minus 1 all multiplied by dy on the left and dx on the right. And lastly, divide through by x, get the last x term on the left hand side to the right hand side. And so we've got brackets 4y over y squared minus 1, close brackets, dy is equal to 1 over x dx. So now we can solve that problem by directly integrating both sides of the problem as it stands. So have a go at that, pause the video, have a go, and then come back and look at the solution if you get stuck, or if you want to see if you're right. So what we're looking at is integrating both sides of this equation. So there's the integral that we're going to integrate. And we quite quickly now will remember that from our table of integrals, we know that the integral of 1 over x is ln x plus c. So the right hand side is done pretty easily, but this side we need to do by substitution. So we go through the substitution process, let u equal y squared minus 1, and we differentiate and rearrange for dy. So dy is du by 2y. Then what we can do is write out that the integral we're trying to find is equal to the integral of 4y over u, and then the y is written as du over 2y from here. So this comes down in there. And then we've got 4y on the top line here, 2y's underneath here, the y's cancel each other out. Okay, the two constants, 4 divided by 2, come outside and become this constant 2 outside the integral, and we've got 1 over u du. We can then use the standard table to say that's 2 ln u, and then lastly replace u with what we called u in the first place, the y squared minus 1, add the constant of integration on the end, and then that's just bringing the two sides of the equation together into the final solution. Left hand side 2 ln brackets y squared minus 1 is equal to ln x plus c, and you'll note that both the constants of integration can come together into one single constant of integration. What you must remember is in these two separate equations, this one, that constant there and this constant up here are different. They could be different. They could be the same value, but they could be different values. And so that's the solution to problem 4 in the notes.